Day 758 of doing a LeetCode problem every day until I get a job. All right, y'all, we're back again another day, another LeetCode problem where we're doing daily LeetCode problems. And today we have question number 2126, destroying asteroids. The difficulty level is medium, but don't worry because you already know we're going to keep the solution as simple and easy to understand as possible. But before we get started, y'all, don't forget to like, hype, subscribe, comment, and share. And if you need any new Apple AirPods, go in and check out that link in the description so you can get you some. Now let's see what the question says. You are given an integer mass which represents the original mass of a planet. You are further given an integer array asteroids where asteroids of I is the mass of the ith asteroid. You can arrange for the planet to collide with the asteroids in any arbitrary order. If the mass of the planet is greater than or equal to the mass of the asteroid is destroyed and the planet gains the mass of the asteroid. Otherwise, the planet is destroyed. Return true if all asteroids can be destroyed. Otherwise, return false. All right, y'all. So that may seem a little bit confusing at first. So let's go ahead and take a look at these examples just to make sure that we are doing this problem correctly. So in example 1, we have our input mass equals 10. That means the planet has a mass of 10, right? It says an integer mass which represents the original mass of the planet. Boom. So the mass of the planet is 10. Then we also have we also have asteroids as part of our input, which is an array of integers 3, 9, 19, 5, and 21. The output is true. So each one of these elements in this array represents the mass of a different asteroid. These are all different asteroids right here. And we want to arrange these in a certain order so that this planet can run through all of these asteroids, because if the mass of the planet is greater than or equal to the mass of the asteroid is destroyed and the planet gains the mass of the asteroid. Otherwise, the planet is false. Otherwise the planet is destroyed. So we want to return true or false. If it is true, that means this planet can run through all of these asteroids after we rearrange the order. And if this is false, that means this asteroid got destroyed. So let's look at the explanation. It says one way to order the asteroids is 9, 19, 5, 3, and 21. So if we rearrange the asteroids in this order, which it says we are allowed to do, right? It says we can arrange the planet to collide with asteroids in any arbitrary order. We choose in this order right here. Boom. So first, the planet that collides with the asteroid with a mass of 9, now the new planet mass is 9, or 10 plus 9, which equals 19. So now our mass is 19. First we do 10 plus, 10, which is our planet, plus 9, which is the asteroid. Now we're at 19. Boom. So now we're at 19. That's our mass. Mass equals 19. Boom. Then we come right here. Our mass is already 19, so the planet collides with the asteroid with the mass of 19. The new planet mass is 19 plus 19, which equals 38. So since this is 19 is equal to this 19, and it says greater than or equal to, that means we could run through this 19 mass asteroid as well. We eat that. Now this becomes 19 plus 38, which gives us 19 plus 19, which gives us 38. So now our new mass is 38. Boom. Let's clean this up. Boom. Then it says the planet collides with the asteroid with a mass of 5. The new planet mass is 38 plus 5. So now right here we have a mass of 38. We eat that. 38 plus 5. It's going to give us 43. Now our new mass is 43. Boom. Then the planet collides with the asteroid with a mass of 3. The new planet mass is 43 plus 3, which equals 46. So now we're right here with the mass of 46. Eat that because with the mass of 43, because 43 is greater than 3. We eat that. Boom. So 43 plus 3, that's going to give us 46. 46. Boom, and our new mass will be 46. Then the planet collides. The planet collides with the asteroid with a mass of 21. The new planet mass is 46 plus 21, which equals 67. So then once again, 46 plus 21 equals 67. Our final mass is 67. We were able to run through all of these, so the output is true. Now, let's take a look at example 2 where the planet gets destroyed. So in example 2, our input mass equals 5, asteroids equals an array of integers 4, 9, 23, and 4. This time the output is false. It says the planet cannot ever gain enough mass to destroy the asteroid with a mass of 23. After the planet destroys the other asteroids, it will have a mass of 22. This is less than 23, so a collision would not destroy the last asteroid. So we return false. So in this case, we could get through this asteroid, we could get through this asteroid, and we could get through this asteroid. And in total, after doing that, we would only have a mass of 22 because 4 plus 9 is 13, plus 4 is 17, plus 5 is 22. That's the highest we can get without this asteroid right here. And since this asteroid is 23 and we can't get higher than 22, that means this asteroid will always win. So that means the planet will always get destroyed. So we return false because it's not possible. Boom. So now that we understand the questions, y'all, let's get into the fun part, the actual solution. The solution is not that difficult at all. Now, first thing we want to do is we want to sort the asteroids in ascending order because destroying smaller asteroids first will allow the planet to grow its mass as quickly as possible. So we're going to say, let sorted R equal asteroids dot sorted, and put the parentheses. Then we need to get the current mass of the planet, so we declare a variable called planet, and we'll set that equal to mass. Then we need to iterate through each asteroid from smallest to largest. So we'll come underneath this, we'll say for I and 0 dot dot less than asteroids dot count. We'll open up the brackets, and the planet can destroy an asteroid if its mass is greater than or equal to the asteroid's mass. So we'll say if planet is greater than or equal to sorted R square bracket I. We'll come outside of that. We'll open up the brackets, and after destroying the asteroid, the planet gains the asteroid mass. So we'll say planet plus equals sorted R square bracket I. Then we'll come right here and we'll say else. We'll open up the brackets. If the planet cannot destroy the current asteroid, it will not be able to continue. So we could just return false right here. Boom. But if all asteroids were successfully destroyed, then we can come down here and we can return true, y'all. Boom. That should be all she wrote. Let's give it a run. Make sure it runs properly before we submit it. Okay, cannot find asteroids. Oh, sorry, it should be an E right here. Then we should run it again. See what happens. It's accepted. So let's go ahead and submit it. Make sure it's still accepted after we submit it. And look at that, y'all. 21 milliseconds beats 75% of users. That's what I'm talking about. That's what I like to see, y'all. So, before we go, make sure you get one more look at the code, y'all. And with that being said, I hope y'all learned something today. And I hope to see y'all here tomorrow for another day, another LeetCode problem. See y'all then.